Hi everyone, my name is Leonard Laxon and I am a consultant here at DEV6. Today we're going to be talking about the Oculus browser and how to build for it with React 360. So what is React 360? So React 360, formerly known as React VR, is a JavaScript framework that is based on Three.js and React Native. And this allows developers to build 360 experiences using VR technologies and JavaScript. As the name implies, we use the same declarative concepts that we have in React and React Native, and we use the Three.js engine for the 3D rendering. So since this framework used to be called React VR, the move to React 360 was more of an emphasis on pushing towards the 360 immersive experiences rather than just a full VR experience in terms of 3D modeling and all those concepts. So that's why the React 360 team wanted to kind of differentiate themselves from other frameworks in that way. So keep in mind that even though I mentioned that React 360 is built on React Native, that doesn't necessarily mean that we can instantly import React 360 applications into React Native, because at the end of the day, the output is React 360 web application, meaning if we want to embed this into our React Native application, then we would have to use a web view for that. So let's talk about the rendering engine. As I mentioned before, the rendering engine is Three.js. And most of the components that we use are React Native components, and we will talk about that later. So for those of you who are not familiar with Three.js, it is a cross-browser JavaScript library that we use to display animated 3D objects. And Three.js is made as an abstraction for WebGL, which is a web graphics library, a JavaScript library for rendering 3D and 2D animations. And this is all compatible with any web browser without the use of any plugins. So similarly, we also have React 360 as an abstraction for Three.js, and this kind of hides away all the extra complexities of Three.js and makes it simple for any developer with the React experience to kind of jump in and create their own VR experiences. So how do we get started? So getting started with React 360 is actually pretty simple. The same way we have create React app and create React Native app, we also have React 360 CLI. As you can see, we just start with installing React 360 CLI, and from there we can initialize our project. And once we go into the project directory, we can start up our local server and actually serve up our files, and we'll see our application there. So React 360, since it's built on top of React Native, it also uses the same bundler that React Native uses, which is the Metro bundler. So this is what the sample project would look like straight out of the box. So in here we have something that is a web application view here. This just gets served straight to your browser. So out of the box here, we have a basic scene with a panoramic image of a nighttime environment. And also in the center, we can see that there's a text component there that says, "Hello, Developer Circles Toronto." And in here, we use a text component to actually render that. And enclosing the text, we have a view. And this is rendered onto a default surface, which is, in this case, a cylinder. That's why you can see a bit of a curve around the user. And this is an example of 2D elements being projected in a 3D environment using React 360. So let's see, this is the file structure that we get straight out the box for React 360 application. I trimmed down all the other extra files, but these are the main files that are more important in React 360 application. So let's break them down. We have the static assets folder, and this is where all of the assets are located. So we can have here 3D models, images, anything like video, that you would actually use in your application, they all live in this folder, and we will explain why that is. Next up is client.js, and this serves as our application runtime. This is where we do a lot of our application configuration, and this basically acts as our bridge between the application and the browser. Next up is index.html, and this is the web page that we load when viewing our application, and this acts as a mounting point for our JavaScript code. Last but not the least, we have index.js, and in index.js, this serves as our entry point for the application. This is where pretty much our React code lives. We can import components into this file, or we can also have, for like very small applications, we can also have all of our React code technically live in this file. And then for production builds, let's say you built like a big application and you want to release it, then you can run npm run build, and that will actually create a build folder for you with all the files that you need in there. However, the static assets folder that you have in your local development, you have to copy that into your build folder. You can use a script to automate that, but you would have to do that manually if you don't have a script. So this is a basic example of index.js. This is pretty much how it comes out straight out the box once you initialize your project from the 360 CLI. And as I mentioned, this is the entry point for our application, and it shows here a basic React class component. As you can see, it uses the React native components here, such as view and text. And view basically acts like a div, and text is basically like a p tag. And at the bottom, you can see here, there's a style sheet which we use to actually style our React components. And this is basically how we also do things in React Native, so it's the exact same way. At the very bottom here, we register our component to the application, and this allows us to basically mount our component into our 3D surfaces. And the string identifier that we have here, which is hello DEV6 Toronto, we will see this in client.js, and this allows us to basically tell React which component to mount into the surface. So in here, this is our runtime, which is client.js, and each React 360 application consists of two main parts. One is our client.js, which is the runtime, and the other is our actual React application, which is index.js. So the runtime itself is what turns our React components into 3D elements onto the screen. And since web browsers are single-threaded, the runtime allows us to basically prevent our rendering to stall by separating our application code from our rendering code. That's why we have the separation between the client.js and the index.js. So client.js relies on things such as executors. So we have something called web worker in this case, and React 360 uses this by default. And these are basically pieces of the runtime that runs your React app in a separate process from the main browser window context. That being said, there are some caveats to this, and we cannot access browser APIs such as, for example, window.location. And in order to access APIs like those, then we would have to use something called native modules, and we can look into the React Native documentation for more questions on how to use that. So let's break down the code here. So at the middle here, we can see that we have render to surface, and basically this allows us to set the root with create root to the hello DEV6 Toronto component, and the string identifier that we had in index.js is used here, and this allows us to mount the component into our VR world. So our coordinate system, we use a right-handed coordinate system in React 360, and for those of you who are not familiar, basically we use the same as the OpenGL coordinate system, which is basically we have it here. This is our Z axis, and this is our Y axis, as well as our X axis. And if we want to move around anything inside our scene, then we would have to familiarize ourselves with this coordinate system, because it's very different from a pixel-based system. In this case, we use meter-based coordinates. And if we want to apply different transformations on any component similar to CSS, the syntax is a little bit different. We have to actually use camel case rather than dash case. And if you want to do multiple transformations to a single object in a 3D space, then you would have to basically make sure the order of transformations that you want are according to how you want them to be executed. So for example, a rotate then a translate is different from a translate then a rotate. So that's just something to keep in mind. So same thing applies as normal CSS. If we wanted to place an object anywhere other than the default coordinate, which is 0, 0, 0, we can use translate. If we wanted to change the object size, we can use scale. And if we wanted to rotate an object, then we would have to use rotate. These are the core components that we have in React 360. And as I mentioned before, they do use the same components as React Native. So at the very top here, we have the view, which acts as the most fundamental component for building UI in React 360. So it acts as a container that supports layout and using Flexbox. And this can contain one or many children, and you can think of it as a div in web applications. On the top right here, we have text, and this is the React component for displaying text. This also supports nesting and styling, and this basically is the equivalent of a p tag in web applications. At the bottom here, now we have image. So this is our React component that displays images. Keep in mind that we must manually specify actual dimensions of our image. Since we use a meter-based system in React 360, it is often difficult to actually predict how our image would look like in a 3D space. So we would have to do a little bit of playing around to actually find the proper proportions of our image. So let's talk about 360 background images. We can do this in two ways. One is from the runtime, which we'll talk about here. We can set the background image if we want to only do it once. So if, let's say, we have a small application and the background doesn't really change, then we can set that in runtime using the set background method here. We provide the path to our image, and keep in mind that it is very ideal in 360 VR space to use equirectangle images such as this example here. That basically maps into our cylinder 3D environment, and it's kind of like a cylinder inside, right? So that's what makes these images so immersive and so real when you're looking through them in a 3D VR headset. Same applies with background videos. You can also set them on runtime if you're not going to change them throughout your entire application. However, the difference between this and the image is using 360 background videos, it's always a two-step process. We have to actually create a video player first and then map that video player to your VR environment, as you can see here. So we can see const player, and then we actually create a video player that we can use, and we can refer to that in step 2, and actually that's when we set the background video in our application. Now that I have already talked about setting the background images and videos in the runtime, we can also do it from our React components. And this is basically how you would want to do it if you want to make everything more dynamic. So for example, if we want to set our background images on component mount, or when the component unmounts, or when the component updates, then we can do that here. How we're going to do that is we need to access the environment module, and from there we can access the set background image or set background video method, and then we just provide the path or the video player in order to actually change our background. So now let's talk about VR interactions. So in React 360, we have something called a VR button, which is equivalent with a button in a web application. And this acts as basically like a container where we can put anything that we would need behavior from. So by default, this doesn't look like anything. So we actually have to manually style it for it to actually look like it's a button or anything that you need. And this is our main way of interacting with objects in a 3D space. We don't necessarily need to click into it. Sometimes we can map events, for example, like gaze-based interactions. If you look at an object long enough, then that's how you basically make a click in the 3D environment. So for example, the user doesn't have a controller, then it's very ideal to have gaze-based interactions. However, if you do have a controller, then you can also just use the VR button just by clicking using your VR controller. Yep. In here, VR buttons support on-click events, on-enter, on-leave. So if you want to have some hover events, let's say change color when you hover on something using your controller, or when you look at something it changes color, then you can apply it in VR button. So loading models. So there's two ways of doing it. We have to use the entity component here, and we can either if you're using the object format, then you can either just have the object by itself, or you can also provide a material which acts as a texture or skin for your 3D model. So that's the one on the left with the actual material. And we use the asset here to actually map to the static assets folder. As I mentioned at the beginning of the video, that's where we put all the 3D models, all the images, all the videos that we need. And it's just like basically like a central hub for all our assets that we can refer to, and we can just use the asset here and provide the path, and it just pulls it straight from there. The entity on the right, as you can see, it doesn't have a material, so it's just the 3D model at its very base. You can still apply lighting and anything that you can do with the entity on the left. It's just it doesn't have any texture or any skins on it. So what if we wanted to be more involved with the 3D parts of our application? For this, we would have to jump into Three.js. So as I've mentioned before, React 360 is a higher level abstraction of Three.js, and it only uses a portion of its features. The main purpose of React 360 is to build user interfaces in 360 environments and not so much into 3D itself. That's why it hides away all the complexities that Three.js gives us. However, if we really want to jump into 3D experiences, then we would have to actually dig deeper into the Three.js API and see what we can accomplish and what we would like to accomplish in our application. That being said, working heavily with 3D models means you might need something that exceeds the vanilla React 360 animation capabilities. That's why you actually need to tap into Three.js or any physics libraries out there to actually make these happen. So when should we use React 360? So like I said, React 360 was created for the intention of building UI, making it easy for a lot of beginner developers, and also for the growing community, the growing React community. They can easily adopt this framework rather than trying to use Three.js right off the bat. But this just mainly revolves around 360 content, and this combines both 2D and 3D interfaces. and this is cross-platform, so it's available on mobile, PCs, and your native VR headsets. So some examples of what you can do with React 360 could be, 360 3D board games, for example. We can have photo and video tours, and anything that's simple, like a museum, for example. You can create an application that replicates a museum. It's just a 360 photo or video of a museum itself, and you can interact with the artifacts or sculptures inside that museum, and those act as our interfaces, and we can create those with React 360. So in the middle here, if you notice, that there's an A logo, and that's the logo for A-Frame. A-Frame is another abstraction of Three.js, and it's another very popular VR framework. And how is React 360 different from A-Frame? Well, A-Frame is heavily component-based rather than UI-based, and it is great for creating more complex 3D scenes, and it works perfectly well in VR as well. And on the other hand, React 360 is more for the 360 experiences and user interfaces. So that's how you pick your framework is just based on what you're trying to accomplish and what your requirements are for your application. You can't really go wrong with either one. They both serve their own purposes. So they're both excellent frameworks to use when you're starting out with VR. And then we've also talked about Three.js. So how is React 360 different from Three.js? Since Three.js is the rendering engine that we use for React 360, it's a lot lower level and a lot more complex if we want to tap into its features, but it's a very powerful tool if you really want to dive deep into creating 3D experiences in JavaScript. So let's do an app demo of something that we've created using React 360. This is basically Aquint DEV6's example application. It's called Shirtastic, and we have this in different platforms as well. We have it in React, Angular, and other technologies that we use. And this is the version that we have for React 360. So let's explore this. So right now I'm using my browser to actually interact with this, but you can also use a VR headset to view this application and interact with it in a VR environment. So here, as you can see, this is our main login page, and we have set a background here that we also use in our main Shirtastic React application. And let's say we continue as guest. Click here, and this is our shop view. As you can see, hover onto a shirt below to see it in 3D, and to dismiss, click on the 3D model to your left. So let's try to hover onto one of these 3D models here. So as you can see, that basically shows us different color shirts based on whatever we hover on. And in this application, I'm actually also using Redux. So for those of you who are familiar with using Redux in normal React and React Native applications, then you can also port that completely into React 360. So let's try to look at my cart. Your cart is empty. Then let's try to add a shirt. So this one, purple. Let's add a black shirt. I don't know, maybe I'll take off the purple and then just keep that. Let's pay. And then here we can just put in 2, 3. And then also, let's say 0 to 23. And then if we check out, we get taken to a confirmation page, and then it says your order is complete, but we can still shop more if we wanted to. So we can just go back and we can go here. So for this application, I've basically used any React technologies that are out there. So I use React Router, and I've also used Redux to actually handle state in this application. So that's why when I said it's very easy to pick up, especially for React developers out there, you don't really have to learn a whole bunch. Like you just have to learn how to integrate and interact with 3D models. But for the most part, it's just a React application, and you can just reuse existing code base that you have in your React web application into React 360. And that will be all for today. Thank you so much. If you have any questions, please comment below.